And let me open the chat in case someone is having a hard time talking. Can you guys hear me all right? Yesterday, some of my students were saying they had a hard time hearing what I was saying, and so I've been using the headset. Can you folks all hear all right?
Yes.
I was going to say, oh my God, I'm being greeted with total silence. Does that mean nobody can hear me? So, okay, all right. All right. Before we get started, we had been looking at linear equations, how to find the equation of a line, how to graph the equation of a line. We looked at graphing by making a table, by using intercepts, and by using the slope-intercept method. Today we're going to look at functions, linear inequalities, and hopefully systems of linear equations, which are all things, most of them are things that ask us to apply what we've learned already. Before we get started with the new stuff, does anybody want to look at any of the old stuff? Anything from homework 15 or any of the homeworks before 15? Anything that we've worked on thus far? Is there any reason for me to pull up and open my labs to look at any assignments? Or are you folks all good? No questions on homework?
No, ma'am.
Wow, I am truly impressed because I want to say that for the last several days, a large part of almost every class has been going over homework problems. But if you folks are good, let's just do a real quick recall of what we did last class by looking at an example problem where we're finding the equation of a line. Whoop. So let's find the equation of a line through the points, let's say 9, 3, and 7, -1. So tell me, folks, what you can remember from last class. In order to find the equation of a line, we need two things. We need what? The slope. And we need a point. With this one, we have 2 points, so that's all set in stone. But we don't have the slope. Can anybody remind me on how we found the slope?
Rise over run.
Rise over run. So if you wanted to, you could plot those points and count blocks. Before that rise over run, does everybody remember we took the difference in the y values over the difference in the x values? And we have 2 points. One point we'll call x1, y1. The other point we'll call x2, y2. Does everybody remember the little subscripts? Just tell me, this is my first point and this is my second point. And so the y value of the second point is -1. The y value of the first point is 3. The x value of the second point is 7. The x value of the first point is 9. And so when I subtract, I get -4 over -2, which gives me 2. Does everybody remember using that formula last class to find the slope of a line between 2 points?
Yes.
So now we have a slope of 2. And we can now use, to find the equation, the point slope formula. And the point slope formula, I like to think of it as coming from cross multiplying my slope formula. It says that y minus y1 is equal to m times x minus x1. Here we know that our slope is 2. And for x1, y1, we can use either of the points. It doesn't matter which. Would you folks rather use the 9, 3 for your point? Or would you rather use the 7, negative 1? Does anybody have a preference? 9, 3 or 7, negative 1?
9 and 3.
Okay, so if I use my point 9, 3, x1 is 9, y1 is 3, and I get y minus 3 equals my slope is 2 times x minus the x value, x minus 9. And if a question asks for my line in point slope form, I'm stopping there. Instead, if a question asks for my line in slope intercept form, oh, that should be an L, not a T, sorry. I have to go through and simplify that a little bit. In order to simplify that equation, does everybody see the need to first distribute? And I'd get y minus 3 is equal to 2x minus 18. And then after I distribute, I want to solve for y, because the slope intercept form is when you've got y alone. So I'll add 3 to both sides. And I'll get y equals 2x minus 15. And that version where y is alone is called my slope intercept form. And then sometimes we're also asked for general form. And general form is when the variables are on one side and the constants on the other. And so here, I want to move the x over with the y. So I'll subtract 2x from both sides. And I'll get negative 2x plus y equals negative 15. And that would be fine for general form. Usually, though, people don't like that leading coefficient to be negative. So we could also take that equation and multiply both sides by negative 1. And we get distributing 2x minus y equals 15. And so that's probably the nicer looking general form. Does everybody remember looking at all 3 versions of the equation of a line? I think everybody's favorite is that y equals mx plus b. So we'd have y equals 2x minus 15. And when we look at that, we see that the slope is 2, which we had found already. And so another type of question that we looked at last class was, if the slope of this line is 2, what's the slope of a parallel line? And what's the slope of a perpendicular line? Does everybody remember if I have parallel lines? That's an awful sloppy writing. I apologize. The stylus is the surface is about a little bit behind my writing, and it's making my penmanship much messier than normal. I'm sorry about that. Parallel lines have the same slope. So the slope of a parallel line would also be 2. And perpendicular lines, remember the slopes are negative reciprocal. And so the slope of a perpendicular line would be negative 1/2. Does everybody remember all of that from last class? Spent a bit of time coming up with it. From this, there are a couple of things that you sort of need to remember. Let's add another page. What you need to know is the slope formula. The slope is the difference in the y's over the difference in the x's. You need to know the point slope formula. Y minus y1 is equal to m times x minus x1. You need to know that the slope-intercept form, y equals mx plus b, and how to use that to graph. You need to know parallel lines have equal slopes. You need to know their perpendicular lines. The slopes are negative reciprocals. And you need to know how to find your intercepts. And for the x-intercept, to find it, remember, we let y equal 0 and we get a point A0. And for the y-intercept, we let x equal 0 and we get a point 0b. Am I just saying words at you folks, or is all of that good? We okay?
Yes.
I'm just writing it down.
Okay, I'll wait a minute then. If that's all right, then we're going to do a slight change in gears for a minute or two, and we're going to look at, oh dear. I might have to disconnect the headset for a minute because I thought I had uploaded some pages to look at in the notes from the textbook. And as I'm looking at it, they are not there. So I'm going to eventually have to upload those. But we'll give it a minute. Is everybody all right connection to the page now?
Yep.
Okay. So today we're going to start by looking at something that's called a function. If you're in this class, you're going to need a lot more algebra past this class. If anybody is on the path to take pre-calculus, calculus, and beyond, you'll spend a heck of a lot of time looking at functions. What we're mostly going to do with functions in this class is define them and look at a little bit of function notation. Before I define a function, though, I need to define a relation. And a relation is just a set of ordered pairs. So a relation is a set of ordered pairs. I could, for example, look at a sort of set of ordered pairs where I have names. I could have, let's say, Smith, John, Doe, Jane. And so this relation would be the set of people's last names and first names. And I'm going to leave a little space because I'm going to go back and fill in a little bit more about this relation in a minute. Another example that I could look at is a set of ordered pairs that are numbers. Let's say 1, 2, 2, 4, 3, 6, 4, 8. And that would be a relation, a set of ordered pairs. I'll leave a bit of space because I want to fill in some more about that in a minute. And one more example, actually 2 more examples. Let's look at 1, 1, 1, negative 1, 4, 2, 4, negative 2. And that would be another relation, another set of ordered pairs. And finally, let's look at another one. 1, 3, 2, 3, and 3, 3. And again, I'm going to leave a little bit of space because I want to go back and revisit each of those. When I talk about a relation, a couple of other terms that you hear, definitions that you need to know, is the domain. And the domain is the set of the first members of each pair. Some people like to think of the domain as being like the X values. And the range is the set of the second members. Of each pair. And some people like to look at the range as being the Y values. And I know sometimes I was always the student that would kind of get words confused. And so what helped me was when I think about my ordered pairs, it goes X, Y, putting them in alphabetical order. And so if I think of taking those words domain and range and putting them in alphabetical order, domain comes before range in alphabetical order. So the domain are the first members, the X values, and the range are the second members, the Y values. And so if everybody's got those definitions down, what I'd like to do is I'd like to go back and look at each of those relations that we formed and see if we can find the domain for each and the range for each. And so if I look at the first set with Smith, John, and Doe, Jane, the domain is the first member from each. So it would be Smith, then Doe, or it would be the set of last names. And the range would be the second member from each pair. So it would be John and Jane, or it would be the set of first names. So if I look at this second set, what would be in the domain? Can anybody help me list the elements of the domain?
One, two, 3, and 4.
3, and 4, the first members from each. And so then the range would be the 2, 4, 6, 8, the second members of each. The next one, the domain, would be the first members. And with this one, when I look at the first members, do you see how 1 is the X value from the first order pair? It's also in the second order pair. But general rule of thumb, when you list a set, there's no need to repeat the elements. So the domain here would be 1 and 4, because those are the only X values that appear. Some of them are repeated, but those are the only distinct numbers. So that one has a domain of 1 and 4. What would the range be? What are my second members?
1, -1, 2, and 2.
1, -1, 2, -2. Beautiful. Thank you very much. And then this last one, what would you tell me the domain is? The first members are
1, 2, and 3.
beautiful. And then what's the range? What are the second members?
3.
Just 3. And it repeats. So there's only one element in the range of that one. So identifying domain and range, all right. If so, I want to fit one more definition at the bottom of this page. And that's what we said we were going to talk about today, a function. And a function is a relation. So a function is just a set of ordered pairs, but it's got something special going on. It's a relation in which each member of the domain is paired with one and only one member of the range. So each first member is paired with exactly one second member. That's the formal definition. A lot of people, when they're looking to see if something is a function, see it as each X value, each first member, is only used once. And so I'm going to scroll back and look at those relations that we have and try to decide if it's a function or not. Can I scroll up and look at those again? If I go to the first one, over here, this relation that pairs last names with first names, does each last name, each X value appear only once?
Yes.
Yes. So this is a function. When I look at that second relation, my X values are 1, 2, 3, and 4. Do each of those numbers only show up as a first member as an X value once?
Yes.
I think that's the only place where 1 is X. That's the only place where 2 is X. That's the only place where 3 is x. That's the only place where 4 is x. So this one is a function. Each x value appears once. Let's look at this next one. Is this one a function? The x value of 1, is it only in one ordered pair, or is it in more than one ordered pair?
It's in more than one, so no.
This one's not a function because the x value of 1 repeats, and also the x value of 4 repeats. In order to say no, it's not a function, it's not that every x value is used more than once. We just have to have a single x value that's used more than once to say that something is not a function. Next one, is this a function? I have x values 1, 2, and 3.
Yes.
Yes, this one is a function. What this one is supposed to point out is the idea that it's not all right for the x values to repeat, but it's perfectly fine if the y values repeat. So y's can be used more than once, but x's cannot. So far, so good. If so, I'd like to look at the idea of a graph of a function. And the graph of a function is the set of points whose ordered pairs are in the function. And we get something that's called the vertical line test. It says a graph represents a function if any vertical line intersects the graph, and at most one point. And so now I have to apologize. I'm going to disconnect the headset for a minute so I can connect my headphones, and I want to upload a couple of pages from the virtual textbook to look at as examples for a few minutes. And then we'll look at that idea of function notation. I'm very sorry that I didn't get this done before class. Can you guys give me about 2 minutes? All right.
Yes.
So, why is this going so slow? And all of these pages will be in the notes so that I had just thought that if I had uploaded the pages into the notes, it would be easier for you folks to look at later than if I just pulled them out of the virtual textbook. So let me know if you think it's worth the effort. Just one more page. And I have to apologize. I did think that I had already inserted them when I downloaded them from the internet. I just guess I hadn't added them to the notes for today. So let's go back to that first function, the first page. And again, these are just copied from the virtual textbook. If anybody has a textbook, it's in there. Otherwise, it's a virtual, the e-textbook. So let me look at number one. For question number one, what would you tell me the domain is? Can you guys see that, or do you need it bigger?
2, 0, -7, and 10.
Is everybody right? No, -7 is that domain. And what's the range of that one?
4, 0, 10, and -7.
Beautiful. And looking at that one, is question number one a function? Does each x value appear just once?
Yes.
Beautiful. Let's look at number 8. Down here, number 8, what would you tell me the domain is? The x values are
1 and 3.
beautiful. What would you tell me the range is? The y values are
2 and 4.
and when I look at this one, is this one a function?
No.
Why not?
The x repeats.
The x value. Now, if I look at, let's look at number 9 first. Looking at number 9, I've got here the graph. Oh Lord, how do you spell domain? I'll just write G. Of relation. The domain is a set of x values. And so as I look at those points, what would you tell me the domain is? What is the x value for each of those 4 points? Everybody right, this point has an x value of 1.
1, 1.
So we have an x value of 1, and this point has an x value of 2. The range, if I look at the y values, this point has a y value of -1. That's -1. That one has a y value of 1. And that point has a y value of -2. But more importantly, I'm wondering, is this a function?
Yes.
Well, are there any 2 points that have the same x value? And when I talked about that vertical line test, that idea that a vertical line can only...
I didn't see that. I'm sorry.
So you see over here, if I draw a vertical line right here, that vertical line crosses through 2 points. And so we're going, at that place, we're going to fail the vertical line test. So this one's not a function. If I look at question number 10, is question number 10, so that one was a no, a function. Is there any place where I could draw a vertical line and have it touch more than one point?
No.
So this one is a function. It passes that test. If I look at question number 11, is this one a function? Is there any place I can draw that vertical line and have it intersect more than one point? That's one, that's only 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 one. So do you see how any vertical line is only going to touch it once? So it is a function. And sometimes I think looking at that, if you have a graph in front of you using that vertical line test makes it easier to determine. Can I go to the next page?
Yes.
So now let's look at, oops, I'll make them a little bit bigger. Let's look at these examples. Over here, if I look at number 12, is it a function? I think if I draw a line over here at x equals -2, do you see how the answer would be no, it fails. 13 has a lot more points, but as I look at those points, does everybody see that this one is a function? Because any vertical line is only going to touch it once. How about number 14? Is number 14 a function? If I picture vertical lines, to see how each one of them would only hit it once. So this one would be a yes. But now, what about if I look at 16? Is 16 a function?
No.
And there are a whole bunch of places where a vertical line would cross that more than once. So that would be a no. Now I am having a brain fart. So I'm going to look at the next 2 pages for a second. Down here, I'd like to look at 67 through 72. And for each of these, we're asked to find what's the domain and what's the range. So let me start with question number, let's start with question number 72. What's the domain? If I look at that graph is just that blue line. On that blue line, does everybody see that all of those points have the same x value? So the domain here would just be the number 3. But now if I look for the range, is there the range of the y values? And so as I compare that blue line to the y-axis, is there a smallest point on that? Well, because of the arrowheads, it keeps going. So there's no lowest point, it keeps going down. And then there's an arrowhead in the other direction, there's no highest point, it keeps going up. So here the range would be all real numbers. Every number, because it keeps going up like my number line does. Does that one make sense? If I look at the question above it, question number 69, this one's a slant line. First of all, I want to start looking at the domain. Are you folks all right if I just use D to abbreviate domain? Is there we've got all of these values in between. We've got arrowheads and both ends. Is there a place furthest to the left that this goes? Is there a smallest X value, or does it keep on going?
Is it -1? Oh, no, it's -1 and 1, right?
Well, those -1 and 1 would be the intercept, but I'm looking at this entire line. When I look at that entire line, you see how it's hard to see on the little blue graph, but they've got arrowheads on each end. And so because of their arrowheads, there's no furthest to the left, there's no furthest to the right. And this domain would be all real numbers. And for this one, when I look at the range, because the line keeps on going down, there's no lowest point. And because the line keeps on going up, there's no highest point. So this one would also be all real numbers. And I'd like to look at 68, but when I copy these out of the virtual textbook, the one thing that I don't like is that it gives me that watermark. So 68 has words in the middle of it. So instead, I'm going to look at 67. And so in 67, when I look for the domain, here I've got arrowheads going to the left. And you see how over here, this arrowhead going to the right says that it will keep on going. And so here the domain is all real numbers. But when I look at the range, I see that these arrows keep going up. But is there a lowest point? Is there a bottom? Well, as I look at it, the lowest Y value is -4. So the range would be that the Y values are greater than or equal to -4. We've got a smallest Y value, and we've got everything larger than that. We could also write that as -4 is less than or equal to Y. Both would say the same thing. Do those make sense? If so, I'm going to come back to some of these in a minute. But can everybody tell by looking at a graph if it is a function, if it passes that vertical line test? And can everybody tell by looking at a graph what the domain is and what the range is? I guess let's look at question 16. It doesn't ask it. But for question 16, what would you tell me the domain is? We've got arrowheads going to the left, so there's no smallest X value. But is there a largest X value? Thinking the furthest to the right that this thing goes, does everybody see the furthest to the right it goes is -1? So here my domain would be that the X values are less than or equal to -1. When I look at the range, the Y values, this arrow looks like it's going to the left, but you see it's also keeping on going down. And this arrow is going to left, but it's also going up. So there's no highest point or lowest point. So here the range would be all reals. And I'm going to do something that I said I wouldn't do. I'm going to go back to question number 15. I'm going to try to draw over it a little bit in another color so it pops out a little bit more over the watermark. And of course I can't draw. And so for this one, if I look for the domain, do you see how X takes on all of the numbers between -3 and 3? So the domain, I think they use set builder notation, is the set of all X such that -3 is less than or equal to X is less than or equal to 3. And in the same way, the range, the Y values, well, there's a lowest Y value. It looks like it's -1.5. And there's a highest Y value. It looks like it's +1.5. So the range would be the Y values such that -1.5 is less than or equal to Y is less than or equal to 1.5. Or my Y values go from a low of -1.5 to a high of +1.5. Take on every value in between. Looking at a graph, is everybody okay with seeing, is it a function or not? What the domain is and what the range is. If so, I'm going to look then at that idea of function notation. And we're going to see that sometimes functions are given by equations. And when that happens, they're frequently named, usually with a lowercase letter. So for example, I could have a function that's y equals 2x plus 5. And I could give that function a name. I could say, let's say that it's f. And so I might say in function f, where y equals 2x plus 5, I might ask you to find y when x equals 5. And so I'm talking to a room full of intelligent college students. If I know that f is given by the rule y equals 2x plus 5, what would you do to find y when x is equal to 5?
Multiply.
What would you multiply?
You would put the 5 in next to the 2.
So is everybody all right? Can I paraphrase what I think you said by saying that what we do is substitute? Is that what you mean?
Yep.
5 for x. And so we get y is equal to 2 times 5 plus 5, which would give us 10 plus 5, or 15. And so that would tell us that when x equals 5, y equals 15, or we could write it as an ordered pair. When x is 5, y is 15. With me so far? Is there anybody else whose hand hurts from doing too much writing? I think that's a lot. And so when we look at the idea of function notation, if I have that function f, which is y equals 2x plus 5, we can write, and we write it f with parentheses x. And we read that as f of x. And f of x just means y. And so previously, where we had written f is the function where y equals 2x plus 5, we could rewrite that as f of x equals 2x plus 5. And these two say the same thing. And then where we said we want to find y when x equals 5, mathematicians are intrinsically lazy and don't like to write. So over here to say find y when x equals 5, instead we'll ask you to find f of 5. And over here, we're being told to use the function f, and because the 5 is in parentheses where x is, we're being told to substitute x equals 5. And so f of 5 would be 2 times 5 plus 5, which gives us our 15. And so we can say f of 5 is 15, which tells us when x is 5, y is 15. Just another way of writing it. So let's try a couple more. Can I turn the page?
Yeah.
So this time, let's give it a different name. Let's say h of x equals 6x squared plus 4. And can everybody look at this and see that that says, is the same as saying y equals 6x squared plus 4. Those two sentences say the same thing. If I ask you to find h of -2, that says the same thing as saying, what's y when x equals -2? So when I have to find h of -2, what I'm going to just do is over here where there was an x, I put in the -2. So over here, where there is an x, I'm going to substitute that number -2. And then I'm going to use my order of operations to simplify that. Parentheses, there's nothing to be done inside. E, exponents, okay, -2 to the second is 4. So that's 6 times 4 plus 4. Then we'll multiply and add, and we'll get 28. So we can say that h of -2 is 28. Same function. What if I ask you to find, let's say, h of 1? In order to find h of 1, what am I going to do? This time I'm going to replace x with 1. And so that gives me 6 times 1 squared plus 4, which would be, let's see, that would be 6 times 1 plus 4, which would be 10. So I'd say that h of 1 is 10, or I'd say that when x is 1, y is 10. Let's say that, another example, let's say that g of x is 5x minus 7, and I want to ask you to find g of 3. I'm going to give everybody a minute to do that. What are you folks getting?
G3 equals 15 minus 7, 15x.
Well, we're replacing x with 3, so that's 5 times 3 minus 7. So I like that 15 minus 7. There isn't an x left because we put in 3 for x. We replace the x with 3. But then what's 15 minus 7?
8.
And so, whoops, it would help if I put the equal sign in there. And so we would say final answer is that g of 3 equals 8. Same function. What if I asked for g of, oh, let's get all crazy, 10. This time where there was an x, we're putting in the 10. And so that would be 5 times x is 10 minus 7. And 50 minus 7 would be 43. So final answer, g of 10 is 43. And when we see this function notation, all we're doing is we're replacing the variable with whatever number is in the parentheses. Make sense?
Yep.
Okay. Then if that makes sense, I'm going to go back to a term that we talked about before with functions, and that was the domain. And we said that the domain was a set of x values. So we can look at the domain as being the replacement set. For x. If we're not told what to use for the domain, so if the domain is not given, It's going to be all numbers for which the expression is defined. All values for which the expression is defined. And so, what the heck is that all about? It's every number that makes sense when I put it in for x in the equation. When I look at that idea of domain, that idea of it being all numbers for which it's defined, there's really only two things that we have to worry about. The two undefined expressions are that we can't have a zero in the denominator, so it'll be undefined if the denominator is equal to 0. And we can't take the square root of a negative number, so something will be undefined if there's a negative under a square root. And hopefully both of those are ideas that you're familiar with. If anybody has a calculator with them to kind of verify that idea, with a calculator, if I look to do something like 1 over 0, the calculator is going to tell me that I have an error. It's an error because it's undefined. I think they might even say something like domain error. Likewise, if I try to take the square root of a negative number, your calculator is also going to tell you that you have an error. It's undefined because we can't take the square root of a negative number. So how does all of this work with domain? Can I turn the page? Yep. I think in the homework you might have 1 or 2 questions that ask something like, if f of x equals, let's say, 10 over x minus 4, we want to find the domain of f. And so as I look at that function, does everybody see that I've got a fraction? And when I have a fraction, when I'm wondering about the domain, what I worry about is that the denominator cannot equal 0. Well, my denominator is x plus 4. If that cannot equal 0, does it make sense that we'd say that x cannot equal negative 4? And so my domain, I can write as the set of all x such that x does not equal negative 4. Or I could write it in a sentence that it's all numbers except negative 4. And one more example. Let's say I have f of x equals the square root of x plus 1, and I want to find the domain. With the square root, I know that what's underneath the square root cannot be negative. So we know that under the radical has to be greater than or equal to 0. So here that would give me x plus 1 is greater than or equal to 0. And when I go to solve that inequality, subtracting 1 from, oops, sorry about that. Subtracting 1 from both sides would give me that x is greater than or equal to -1. And so my domain would be all values greater than or equal to -1. And so that's what we need to know about functions. I think there's only 1 or 2 questions that ask for the domain from an equation. Otherwise, you're going to be finding domain by looking at a graph or looking at a set of ordered pairs. What's probably most important that you get is the idea that the domain are the x values, the range of the y values. If it's a function, each x value can be only used once. And that function notation, that idea that f of x is just a fancy way of writing y. And if there's a number in the parentheses for x, we have to substitute. If those are all right, I hate switching gears so much, but with the 2-hour class, we really do have to cover like 2 sections more or less in each class. The next place we're going is to look at the graph of a linear inequality.
Can you just repeat the last thing you just said about function? I know I got domain is x values, range is y, and I wrote them down before, but.
I'll tell you what, we'll just rewrite them before we start looking at the graph of a linear inequality. So for a function, it's the set of ordered pairs.
Okay,
The domain are the x values. The range are the y values. It's a function. Each x is used only once. When we're looking at a graph, we can use that vertical line test. And then when I look at function notation, f of x is just a fancy way of writing y. And if I have f of some number, what happens is it means that we're going to substitute that number for x. And that's what's most important, that you get away from functions. Better?
yeah, thank you.
You're welcome. Thank you for asking. So now we're going to switch gears a little bit. We're going to go back to graphing, and we're going to graph.
Can you go back to that for 1 second?
If I'm going to go back to that for 1 second, I'm going to take the headphones off and take a sip of coffee. Give me a minute. Oh, so Betty? Ready, folks? Can I turn the page or not yet?
Not yet, just 1 second.
Okay, just yell ready when you're ready. You don't have to yell, you can just say it.
I like the little review at the end, because then once you go through all this and I'm like, you get it a little bit better. How was your meeting?
Alrighty.
It was interesting. It was interesting. It was mostly about how COVID has affected every school.
Yeah.
So it's financially, it's hurting everything in the state. So see what happens. So we've been graphing equations, which are lines, right? The graph of a linear equation is a line. I could have ax plus by equals c, or I could have y equals mx plus b. And if there's an equal sign, the points fall on a line. If I have a linear inequality, instead of having an equal sign in inequality, I'm going to have one of these symbols that we looked at previously. This first one is less than. The second one is greater than. This one is less than or equal to. This one is greater or equal to. And again, we had said that when I look at y equals mx plus b, or ax plus by equals c, when it's equal, all of the points are on the line. And so if it's equal when it's on the line, it's not equal off the line. Y does not equal mx plus b, or ax plus by does not equal c. And if it's not equal off the line, what happens is on one side, it's greater than. On the other side, it's less than instead of equal. And so if I want to graph a linear inequality, there's 3 steps that I have to do to graph an inequality. The first thing I have to do is I have to determine what type of border that I have. If I have ax plus by, let's say, is greater than or equal to c, or if I have ax plus by is less than or equal to c. Does everybody see with both of those symbols, I'm going to include where it's equal. So I'm going to include the line, and I show that by using a solid line. Instead, if I have ax plus by is strictly greater than c, or ax plus by is strictly less than c, it's not equal. So we do not include the line. So instead, we use a dotted line. So far, so good. And then after we graph the boundary line, we have to decide which side of the line to shade. In order to do that, we're going to pick any point off the line and check it in the original inequality. When we do that, if it's true, we shade to include that side of the line. That side of the line. If it's false, we shade the other side. And so I am guessing that that's probably about as clear as mud right now. So can we look at several examples, first by hand, and then I'd like to show you how you do it in my labs with their graphing tool. Does everybody have the words down before we look at an example?
Yes.
So first example, let's graph 3x plus 3y is greater than 3. First of all, does everybody notice this is not an equation because there's no equal sign? We've got a symbol of inequality. Because that's less than, it tells me that I'm going to draw a dotted line. Is everybody all right with that decision? Now that I know it's dotted, I'm going to graph the line. And on the line, we've got that 3x plus 3y equals 3. I like to use my y equals mx plus b to graph my slope-intercept form. So I'm going to solve for y, giving me, subtracting 3x gives me 3y equals negative 3x plus 3. And then to get y all alone, I have to divide both sides by 3. And I get y equals negative x plus 1. When I compare that to my y equals mx plus b, I need to first draw some axes. when I compare, does everybody see that B is 1? So I begin at 1. We always begin on the Y line. Then M is -1. As a fraction, it's -1 over 1. So -1 tells me I'm going to move down 1, then over 1, down 1, then over 1. And so my line would be going through these points. But again, I'm not making a solid line. I'm making a dotted line. Is everybody comfortable graphing the line? Now, I want where, oh, I got to go back up to the original problem. 3x plus 3y is greater than 3. So I've got to shade one side of the line or the other. To decide where to shade, I need to take a test point. And the test point would be any point that's not on the line. But my favorite test point is 0, 0. Doesn't always work, but it usually does work. So I'm going to test that in the original, which was that 3x plus 3y is greater than 3. So I'm going to put in 0 for x and 0 for y, which gives me 0 is bigger than 3. Is 0 bigger than 3? Since that's a no, it tells me I want the other side of the line. So we'll shade the other side of the line. So because my point 0, 0 didn't work, I'm not going to shade that side, but instead I'm going to shade the other side. So far, so good. We're doing what we did last class, graphing lines, but we have to, before we do our graph, decide is it a solid line or a dotted line? And then we have to color in on one side of the line or the other. Should we try some more?
Sure.
So next one, let's look at y is less than or equal to 3x. And so now I'm looking at that symbol. And is this going to be a solid line or a dotted line? Because that equals in there, whenever that equality is in there, it's going to be a solid line. Now my boundary is where y is equal to 3x. I don't have to solve for y, that's done for me already. When I compare this to y equals mx plus b, does everybody see that there's no b written? So b is 0. So I'm going to start at 0 on my y-axis. M, that was the x coefficient, it's 3. I like to think of it as a fraction. So it's 3 over 1. Because it's positive, it means that from my point, I'm going to go up 3 over 1 of 3 over 1. And this time we decided that we were going to connect with a solid line. Yeah, I'm not doing real well drawing today. Is everybody all right, though, that that is a solid line? Now, to test, I can take any point I want as long as it's not on the line. So here, 0, 0 is not a good test point because it's on the line. So is everybody okay if for my test point, I use this one over here, 2, 1? And so if I test the point 2, 1 in my original equation, y is less than or equal to 3x, y is 1, x is 2, and that gives me that 1 is less than or equal to 6. Is that true or false? Is 1 less than or equal to 6?
True.
True. And since it's true, we like that point. We like the side of the line that's point is on, and so we're going to shade towards the point. I'd like to do a couple more examples, but the examples that we're doing right now are pencil and paper examples. And when you're doing your homework, you're going to be working in My Labs. So let's do an example from the homework in My Labs so that you can see how you do that shading there. All right? So, the assignment manager, and let me make sure that this is, oh, this is not your class. So let me go into the homework for your class. Nope. It's not going to let me do it that way. Let me go into your class. My Labs. And I guess I'll just go into all the assignments. Pretend I'm, oh, it's not going to let me pretend I'm a student, I think, because my access, I think, ran out. Oh, yes, it is. Okay, and we're looking here at homework. Number 17, graphing linear inequalities in 2 variables. And so I'm just going to pick a random question. Hopefully this is a good one. And so they want me to, oh, you know, this is real similar to the one we just did. Let me pick them. Yeah. Here I've got the equation x plus y is less than or equal to -5. First decision I have to make is, am I going to use a solid line or a dotted line?
Solid.
Solid because I'm including equal, great. Then the next thing I have to do is find the line. And so to find the line, it's going to be the line x plus y equals -5. Again, I like that y equals mx plus b. So I'm going to get the y alone and get y equals -x minus 5. when I compare it to y equals mx plus b, b is -5 and m is -1 as a fraction, -1/1. Now, let's see how steady my finger is. I'm going to make that bigger. Ah, I got to turn my finger back into a mouse. I'm going to make that bigger. And as I make that bigger, does everybody see over here? Let me draw again. Does everybody see over here? It lets me decide, do I want a solid line or a dotted line? We already decided solid line. So I'm going to keep that. If I wanted a dotted line, I'd press on the dotted line, but I want the solid line. And I'm going to pick on the line tool. So the line tool is the one next to the arrow. We said we'd begin at -1. So I'm going to go through and I'm going to click on -1. And then we said our slope is down 1/1. So from there, I'm going to go down 1/1 and click on a second point. And do you see how it gave me my line already? Now, I've got to do a little bit more work. I have to decide where to shade. And in order to decide where to shade, I'm going to pick a test point. Is everybody all right for my test point? My favorite point is 0, 0 if it works. And I go to the original. X plus y is less than or equal to -5. X is 0, y is 0. And is 0 less than or equal to -5? No, 0 is not less than a negative. What was I saying there? That's false. I don't want that side of the line. Now, the next part I think is really fun. Is there anybody else who's sort of a little kid that ever wanted to just pour a bucket of paint to see where it went? Take a bucket of paint and just dump it over and see what happens. We get to do that. In order to shade, I'm going to pick the bucket of paint on my toolbar. I'm going to turn my finger back into the mouse. I'm going to pick the bucket of paint. And we said we didn't want the point 0, 0. Yeah, no, so we're going to just dump our bucket of paint on the other side. And we dump the bucket of paint by just clicking on it. And so yeah, we've got the solid line that we wanted, and we shaded away from the point. So far, so good. So I'm going to click save. And let's check our answer. Woohoo, well done. And so this process of doing it in my lab's all right. Should we try one more?
Yes.
So I'm going to clear this because I've scribbled all over this one. And let's see. This one's not that different. I'm going to look for another one that's a little bit more different. No. Oh, this is a fun one. This one, we've got y is less than 5. First of all, I'm looking at that symbol of equality and I have to say solid or dotted.
Dotted.
If there's no equal sign, it's going to be dotted. Then I have to find my line. And my line would be where y is equal to 5. Oh boy. Y is all alone, but I don't see that whole y equals mx plus b. I guess because that 5 is all alone and there's no x attached, we could say that b is 5, but there's no m. When there's no m written, Do you remember that means that your slope is 0? Or do you remember when it's just y equaling a number, it's a horizontal line. So this time I'm going to pick the dotted line tool. I'm going to begin at 5, and I'm going to get a horizontal, whoa. Oh, I got to pick the line tool. That's why it's not working. I'm going to begin at 5, and I'm going to make that horizontal line. And does everybody remember if it's just y equals with no x, it's a horizontal line. Now, for my test point, if I test with the point 0, 0, and y is less than 5, is 0 less than 5? That's a yes. And so when I pick my bucket of paint, I want to include the point. And so I shade there. I dump my paint there. Is that one all right? Let's save it and let's check. Yes, we did it. And so are you folks comfortable with finding the right tools in MyLabs to do this, whether it's a solid line or a dotted line? Make sure you pick the line tool, then take your test point and dump your bucket of paint. If we get a yes when we test, we dump the bucket where the point is. If we get a no when we test, we dump the bucket on the other side. All right? If that's the case, I'm looking at my watch and I'm realizing that I probably could have talked faster, but I don't think you guys would have liked me if I talked faster. And so I'm going to, didn't get quite as far as I wanted. So don't worry about number 18 on the homework. You know what? I didn't want to draw with that. I wanted to draw with that. Don't worry about number 18 on the homework. That one will be due, the homework 18 will be due on a week from today, the 13th, as will the problem set. And the test will be after the 13th, but before the 15th. And what we'll do on the 13th is we'll go over a problem set, a preliminary test. Did that help you folks last time when we did a problem set, a practice test together before the test?
Yes.
All right. So if that's okay, I'll make sure I make that change in MyLabs. But let me stop sharing my screen. I'll stop recording.